Okay, so we got a nuclear reaction. How many neutrons will be emitted, right? Plutonium is 94, element 94, right? So it's going to be 94, 239, right? Turns into 136.54 xenon, right? And 9640 zirconium, and that's ZR, right? Plus some number of neutrons, right? That's supposed to be the letter N right there, right? Okay, so how many neutrons are we missing? 40 plus 54 adds to 94, so that works, right? 136 plus 96, right, is 232, and this is 239. So I think we're missing 7 neutrons, right? Okay. Write the nuclear equation. So 7 neutrons, that's the answer to that one, right? Write the nuclear equation, there it is, right? How much energy is released? Well, we're going to take this mass here, the 239.052158, right? So take this mass, right? Subtract this, subtract 7 times this, right? And get an answer. Okay, so minus 95.908275 minus 135.907213, whoops, 907213, right? Minus 7 times 1.008664. I expect that number to be a 5, but maybe in Britain where they write these books it's a 4. Maybe that's the new value for it. Okay, so 5, let me just double check. 52158, 52158, 908275, 908275, 907213. I'm just double checking my numbers. 008664. Okay, so the mass defect for this that I get is 0.176022 U's, right? And then I'm going to multiply by 931.5, and that's MeV of energy per U, right? So the energy is 163.96 MeV, right? Okay, so how much energy is released? 164 MeV, right? What is the mass of 1 mole of plutonium? Is that a trick question? Mass of 1 mole of plutonium, if it's purely that, is this many grams, yeah? Yeah. Who's buried in Grant's tomb? I almost said Tant's groom. What would have happened if I'd said that? How many atoms are there in 1 kilogram of plutonium? Oh, good God. Okay, so I'm going to go 1,000 grams divided by 239.052158, and this is grams per mole, right? Okay, and then I'm going to multiply by avocado's number, 6.02 times 10 to the 23rd, and that's atoms per mole. We're running out of space. All right, so, okay, hold on. Storage A, that's my mole, my energy. Okay, let's go 1,000 divided by 239.052158. I've got all that precision. I might as well use it, right? Storage B. So how many moles, how many atoms are there? I'm getting 4.18 moles. So times 6.02 e to the 23rd. That's a buttload of atoms. Okay, I'm getting, where do I write it? I'm going to write it up here. Number of atoms is 2.518 times 10 to the 24th atoms. Is that what they got? 2.5. Yeah, there we go. Atoms. Okay, so we're getting the right answers. 239 grams, how many atoms, right? Okay. How much energy in electron volts is released if 1 kilogram of plutonium undergoes fission? Oh, good God. So that's going to be that many atoms times that many MeV, right? Okay, so that times clear. Alpha C is that. Alpha A is my thing. Okay, so alpha A times alpha C. These are just numbers I've stored in my calculator. I am getting the amount of joules in electron volts is, well, it would be 4.13 times 10 to the 26th million electron volts. Yeah, that's what they give, right? 10 to the 26 million electron volts, right? Convert that answer into joules. Well, that's not hard, right? This has got to be 10 to the 6th, right? The million, right? And then just multiply by 1.602 E minus 19, and that's joules per electron volt, right? So I'm going to go this times 1E6, right? Divided by, or no, not divided by, times 1.602 E minus 19. And I'm getting 6.615 times 10 to the 13th joules. Yeah, which is that answer there. Yay! Yay! If you scribble hard enough, you can actually get like the thing, it just goes away. It's like not even there. There you go. Equatio. All right. I'm feeling goofy. I got to go pick up my kids from track.